5 temperature measurement problems that the new visual IR thermometer solves. Good morning, good afternoon and good evening. My name is Alan Thompson with Fluke, based in the UK, where the visual IR thermometer VTO2 is manufactured. The purpose of this presentation is to demonstrate 5 temperature measurement problems and show how a product like the VTO2 can help resolve these issues. The agenda for today is an introduction of how does infrared work. We'll run through the basics of infrared theory and show you how to get the best from a non-contact temperature measuring device. 5 temperature measurement problems that the new visual IR thermometer solves. We'll run through the major questions you're faced with when working with non-contact measuring instruments and how the VTO2 can be utilized to help solve these problems. We'll then have a quick conclusion. For those listening to the webinar live, there's an opportunity for questions and answers. If you're listening to a recorded version of this, there'll be a website and email address at the end where you can direct questions. Introduction. How does infrared work? Radiated heat is electromagnetic radiation in the infrared band of the spectrum. Absolute zero is minus 273 degrees C, and all objects radiate thermal energy above absolute zero. As an object becomes hotter, its molecular activity increases, and it radiates more energy. Heat transmission. Heat is transmitted by conduction, where an object transmits its energy through contact with another object. Convection, where an object transmits its energy through a liquid or gas, generally not a solid. And radiation, where energy is transmitted in wavelength form from a solid surface. Here we are only concerned with radiation. In 1800, Sir William Herschel tested the relationship of radiated heat and light. He split white light into a spectrum and, masking all the colors but one, measured the individual temperatures of each color. He found the red end of the spectrum was hotter than the violet end, but also found that an area where he could see no color, next to the red end of the spectrum, was hotter than the rest of the spectrum. He called this invisible area infrared, or below the red. The electromagnetic spectrum covers all electromagnetic radiation from the short wave gamma and X-rays to the long radio waves. It includes the visible band, which we see with our eyes. The infrared radiation just sits beyond the visible. Infrared thermometers work by focusing emitted infrared thermal radiation onto a detector. A thermometer gathers energy through a special material optical lens and focuses that energy on the detector that sits behind the lens, converting that to an electrical signal. Depending on the amount of energy transmitted through the lens, the detector will generally go through a voltage change. It then displays the temperature. Through the unit's internal software, this voltage change can be read and converted into a temperature. Emissivity. In order to make an accurate temperature measurement, you need to know the emissivity of the material you're measuring. Selecting the correct emissivity will have a big impact on the accuracy of the object you're measuring. Emissivity is a rating of a material's efficiency to radiate infrared energy. All materials on the planet have an emissivity rating. If you do a search on the internet on the material you plan to measure, you can easily find its emissivity value. Some IR thermometers do not allow you to adjust emissivity, but this feature is available with the visual IR thermometer. Generally, those units would have a preset of perhaps 0.95. However, the emissivity value on the VTO2 can be set in increments of 0.01, giving the ability to measure accurately any material. Emissivity. The hand above is in the same temperature as the ring, but as the ring reflects more than the hand, it will show a different temperature unless the correct emissivity is selected. Human skin has an emissivity of 0.98, whereas gold is very reflective and could have an emissivity value as low as 0.37. Selecting the correct emissivity will greatly improve the accuracy of your measurements. If you don't know the emissivity value of the material you're measuring, and if it's possible to to do, you could apply black tape to the object and set the emissivity around 0.98. Traditional IR thermometers may be sufficient. For basic spot checking, where the precision and exact location of issues is not critical, a spot thermometer will provide an average temperature reading over a circular area. The further you are from the object, the greater the area. This is expressed with the unit's D to S ratio, distance to spot. For example, a unit with a 10:1 D to S ratio would mean that from a distance of 10 feet, the diameter of the object you're measuring would be 1 foot. For getting single-point measurements where a limited number of temperature readings are needed, being lightweight and easy to use, a single-point thermometer is a fast and efficient way of checking single points of temperature measurement. However, traditional IR thermometers have limitations that can cause problems with temperature measurement. Let's look at the first problem. Problem 1. You're trying to accurately measure a specific target. However, you're unclear if you've captured an accurate temperature. Remember that temperature guns measure only an average surface temperature. So the distance to spot ratio. You may have to get very close to your target in order to get any more than an average temperature of what you're measuring with an IR thermometer. Going back to the D to S ratio, you might have to get very close to the object to get an average temperature to ensure it's not too hot. If the area you're measuring is greater than the object and includes such things as the DIN rail it's mounted to, the DIN rail will be at an ambient, and the component in fact hot. You will get an average temperature of the DIN rail and the hot component, which could lead you to a conclusion that the object is okay. Without any visual image, how can you be sure that you're measuring only the target spot and not getting an average of the temperatures of surrounding objects? If this is the case, you might need to consider an alternative solution. How the visual IR thermometer solves this problem. With a visible image of what you're measuring, you can be sure that you're measuring the target. With this example, you can see the center measuring cursors within the object being measured. It's worth noting that you should ensure that the surrounding pixels are also within the area to be measured. It's also worth noting that by combining a temperature heat map and a visual camera, you can get contextual information. You can see to the right of the object the number 20, so you know exactly which object you're measuring. No more worrying about distance to spot ratio. By using a heat map, you can quickly see how close you need to be to the object to get an accurate temperature measurement. Problem 2. You have to take many multiple grid readings and manual temperature measurements to assess a piece of equipment. Let's take a look. You need to get out a notebook and pen and painstakingly write down each measurement you make. Significant drain on productivity. For complex and multiple temperature measurements, this can be very time-consuming. Each individual component needs to be documented in a notebook and each measurement noted down. Generally, faulty components are identified if their temperature is significantly different from other components operating in the same environment. Once all the readings have been documented, the operator has to do the maths to identify the problem. This is prone to error if the operator misidentifies a component or makes an error in his maths. How the visual IR thermometer solves this problem. The VTO2 lines up a visible image with a thermal heat map. By using both a heat map and a visual camera, which are lined up and overlaid, both the component's temperature and its tag, in this case number 20, are clearly displayed. Blend the resulting images to 0, 25, 50, 75 and 100% opacity, both on camera and in the software. The user has the ability to blend the image from 100% thermal to quickly identify hotspots or areas of concern, down to 0% thermal and 100% visual to show a full visual image of the component. Note that in a full visual, the temperature is still displayed, as the thermal heat map is always switched on even if not displayed. See temperature measurements in context with what you're measuring. By displaying an image of multiple components, you can quickly see temperature anomalies with the contextual image of which components are demonstrating higher than average temperatures. No need to write anything down. All images can be saved on a micro SD card. Images of both the thermal heat map and the visual are saved simultaneously for more detailed analysis via SmartView software, which is provided with the VTO2. This also allows for recording a faulty component, then recording once the component has been fixed. Problem 3. With a temperature gun, you may miss hot spots or cold spots that may indicate an issue. Let's take a look. Having a set of measurements will not intuitively tell you there's a problem. When making multiple measurements with an IR thermometer, you cannot quickly identify temperature anomalies. Each temperature value has to be written down and then analyzed. This is time-consuming and prone to error. It is difficult to interpret measurements as hot spots and cold spots. They are in fact just measurements and don't necessarily stand out as anomalies. How the visual IR thermometer solves this problem. With hot and cold spot markers, you can instantly see the hot and cold spots on the thermal heat map. With the VTO2, you can switch on hot and cold trackers. These trackers will automatically seek out the hottest and coldest points in the field of view of the unit. Hot and cold spot markers drill down further on the issue at hand to help you identify the source of the issue. Once you've found the hot spot or cold spot you're looking at, you can center the spot on the unit for temperature measurement. Problem 4. You find it difficult to picture or remember exactly where the potential problems are. Let's see. Visual inspections. No issues are obvious to the naked eye. As we know from the earlier slide on the electromagnetic spectrum, you can't see temperature with our eyes. We need another method to measure this. Traditional IR thermometer. These are optimized for single-point measurement. A quick way of measuring a single point of temperature over an average area, but limited if multiple temperature measurements are needed. Full infrared-only thermal imagers. Challenging to see exact location without visual context. A great way of quickly identifying temperature anomalies, but without a visual camera, it's difficult to be sure of the exact location of the component being measured. How the visual IR thermometer solves this problem. With a blended image, you can picture exactly where the problems are. By combining the best of a single spot temperature gun and a thermal imager, you can quickly find a hot spot or temperature anomaly with the unit's thermal heat map and the contextual information of which component is demonstrating an anomaly with the unit's built-in visual camera. The date and timestamp on saved images helps you keep track of temperatures over time. All images saved are automatically date-stamped to provide a quick audit trail and can be recalled on the VTO2 screen or downloaded to a PC for further analysis on the supplied SmartView software that can provide both analysis and can further generate a report. This can be very useful in identifying to the plant owner areas of concern or further reports showing a component has in fact been fixed. Both visible image and thermal heat map are saved, so you'll always have all your measurements available. Perhaps you're measuring an area over a period of time and you're more interested in changes rather than temperature anomalies. You can regularly save images. The supplied micro SD card can save thousands of images and carry out analysis by comparing changes. Problem 5. You lack an easy way to communicate issues or document that repairs are completed. With an IR thermometer, you will need to write out measurements. As described earlier, this can be very time-consuming and prone to error. Describe the location and equipment. With a complex piece of machinery, such as a pump set shown, it's difficult to describe the point where your measurement has been taken. If you're measuring a bearing housing without the benefit of a visual camera, it would be hard to describe the point of measurement and to duplicate that point on a subsequent visit. Detail your conclusion. Without the benefit of saving an image and the ability of software to produce a detailed report, any conclusion would be anecdotal at best. How the visual IR thermometer solves this problem. Producing a professional report with the included SmartView software is just as powerful as the VTO2 tool itself. Through the software, you can make further adjustments to your image, such as correcting the emissivity value if you didn't know it on site, reblending the image fusion for greater thermal or visual clarity, and finally producing a professional report. You will be able to communicate the issue that you've detected or document repairs that have been fixed. These reports can then form an audit trail to ensure remedial work is carried out and proven to be carried out to the plant owner, and provide an audit trail showing changes to plant machinery or control panels over a period of time. The software is license fee free with unlimited usage. By providing unlimited software usage, every user of the VTO2 can have the software on their own PC. As the VTO2 uses a removable micro SD card, all users can also have their own SD card, thus allowing the VTO2 to be a shared resource. Visual thermometer technology strikes the perfect balance between performance and affordability. Hyper-thin pyroelectric technology creates an infrared heat map. Fluke's unique pyroelectric technology allows the VTO2 to produce a thermal heat map showing a temperature profile within the unit's field of view via a 20-degree thermal lens. Elusive technology until now. This technology has been developed over a number of years to the point now where it can be used to great effect in the VTO2. This technology is unique to Fluke. Incorporates features found only on advanced thermal imagers at a much higher cost. Due to the low cost of this technology, the visual IR thermometer incorporates many of the features of higher cost thermal imagers at an affordable price for many contractors. Now contractors can arm their engineers with the VTO2 to enhance their thermal imaging capability, provided at supervisory level. Built-in intelligence eliminates the need to have advanced knowledge of thermal imaging. With a simple menu structure, the VTO2 eliminates the need for a detailed knowledge of thermal imaging. Areas of concern can be quickly identified with the VTO2, while more detailed analysis can be carried out through the provided software, SmartView. I'd like to welcome any questions. While we're running through the question and answer sessions, I thought I'd read through some of the reviews of the VTO2. For those who are listening to a recording, at the end of this presentation is a phone number, a website, and an email address where those questions can be directed. The reviews are in. Having a visual image provides context. It is hands down the best way to take temperature measurements. Even with a thermal imager, I'm not sure what I am looking at. The visual image is key. The more I use it, the more I like it. From a master electrician. This is a cool product. I can see tons of HVAC applications for this tool. I'm an HVAC instructor and would definitely be a tool that I would show to all my students. An HVAC instructor. I already have a thermal imager and this is very cool. I would definitely see my crew owning a few of these. Electrical contractor. When is this product available? I'd like to order one now. Can I purchase this right now at the trade show before I go back home? A utility contractor. And the answer to that one is yes, the product is available. So if you want more information, technical notes or product information, you can contact Transcat on 800-828-1470. The web address is www.transcat.com. The email address, sales@transcat.com. Thank you very much for your time and thank you for listening.